Okay, so we're going to begin 5-2 exponent rules. This video I'm actually doing from my iPad, so it's going to look very electronic. You won't see my hand and the pencil. You'll just see my notes as we go along. I'm kind of doing them both ways so you can see both ways of me doing a video, and then we can talk about which one you prefer. But for this time, this will be what it is. So we've already actually talked about product rule, power rule, and quotient rule. So this is a little bit of a review from 5-1. So for a product rule, we remember that with the same base, we add the exponents, or add the powers. Okay, so as long as our base is the same, we can keep it there. And then all we have to do is add the 5 and the 3 together. So that in fact gives us 8 to the 8th. Remember that if you do not have an exponent showing on any base, y, but that is not y to the 0, it's actually y to the first. And that's a really important thing to remember, because if you don't, you're always going to be off by 1. So y to the first, 4 is the same thing as 4 to the first, 12 is the same thing as 12 to the first. If this is not automatic for you at this point, you need to write that 1 in there until it does become automatic. Okay, so now we've got the same base, we can just add the exponents, and so we get y to the 10th. Down below, I've got the same base, just 3 different times, a here, a there, and a there. So I just need to add those 3 exponents together, and I get 4 plus 3 is 7, plus 10 is 17. Finally, here we need to deal with the coefficients first. I think it's easier to deal with those coefficients first and just multiply those together. So 2 times 3 is 6, and then I can just add those exponents together, so I have x to the 9th. Okay? All right, let's work on the power rule a little bit. Remember that when you're raising a power to another power, power to a power, we're going to multiply the exponents. If you need an expanded version of that, go back and refer to your notes on 5-1. Okay, so for the first one, I just need to multiply 4 times 3, and that gives me 7 to the 12th. Next one, my base is x, and I have x to the 5th raised to the 2nd power, so I need to multiply 5 times 2, which gives me x to the 10th. Now, on this third example down here, remember what you've got going on. You are raising each of these bases to the 2nd power, okay, like a distributive property. And remember that if you don't have a power, then you need to put the 1 on that. So our first base is going to be negative 10, and 2 times 1 is 2. And I'm going to put parentheses around that because of that negative sign, okay, just to be sure. And then x to 6 times 2 is 12. So if I really wanted to simplify that, I would write that as negative 10 squared is 100, x to the 12th. Okay? All right, finally our last one. Let's just write that out in expanded form. So we have 1/3 squared, x squared, and y 3 times 2 is 6. So now I can go ahead and multiply this out. 1/3 times itself. 1/3 times 1/3 would be 1/9 x squared y to the 6th. Okay? Okay, pressing ahead. Quotient rule. Remember, that means I always think of it as, do I have more on the top than on the bottom? But what you are doing is you are subtracting the exponents as long as you have the same base. Okay? So our base there is 2. 11 minus 6 is 5. What I think of is, do I have more on the top or on the bottom? So in this case, I've got 7 on the top, 4 on the bottom. I have more on the top by 3 which means this is not a fractional exponent. It's just, or if your answer is not a fraction, it's just, this is really over 1. So, and then here we have 5 minus 3 is 2. So the base for this was 2, our base here was -4, and our base here was x. Okay, when you get down to the more complex fractions, remember that these can actually be written as separate fractions that you can then simplify. And so you can really think of that as 3 over 12, which you can reduce to 1 over 4. And then I have more y's on the top, so that's going to stay up there with that. And I have more by 6. Okay. Same thing even with this complex one. Now you can just make yourself a new line and decide what you have where. So 6 over 2 reduces to 3 over 1, or just 3. You can actually keep that 1 out of there, or leave it down there, doesn't matter. And then here I've got 9 x's on the top and 1 on the bottom, so I have more on the top by 8. I have 4 y's on the top and 2 y's on the bottom, so I have 2 more on the top than I do on the bottom. And finally I have 5 z's on the top and 4 on the bottom, which means I have 1 more on top than I do on the bottom. And this is really all over 1, or you can just write it 3x to the 8th, y to the 2nd, z to the 1st. Good. Let's move on to the second page. So, again, let's just kind of review what we've done now. So 2/3 to the 3rd power really means 2 to the 3rd over 3 to the 3rd. So if I'm going to simplify that out, 2 times 2 is 8, and 3 times 3 times 3 is 27. On our second problem, x to the 3rd power is just that, and y to the 3rd on the bottom. Finally, we have 2x to the 3rd, and remember that means that everything in that parentheses is being raised to that power. And then we just know that 2 times 3 here, or you can think of it like this, y squared to the 3rd power, and then simplify. So 2 to the 3rd power is 8, x to the 3rd on top, and then 2 times 3 would be y to the 6th on the bottom. Okay, so let's go back to, remember that you've normally heard the phrase PEMDAS, and you're going to start hearing GEMDAS a lot more often. And that's because in PEMDAS, that P stands for parentheses, but it really kind of doesn't contain all of the situations that can occur in an expression. So instead of parentheses, what we like to use is grouping. And that includes parentheses, brackets, absolute value, any of that. Okay? And then E stands for exponents. And then multiply and divide. And then add and subtract. So the rest of the PEMDAS is the same when we switch it to GEMDAS. It's just that grouping. So it includes parentheses, brackets, absolute value bars. It includes all of that. Okay, so let's do first things first. So if I go in this order that I've got up here, I don't have any grouping going on down here because I have no parentheses, brackets, or absolute value, but I do have exponents. So now using our rules, let's deal with that first. And so I know I've got y to the 3rd times y to the 7th. So I know that I have to add my exponents. So 3 plus 7 is 10. And then my coefficients, I can just multiply those together, and I get 30y to the 10th. If this situation is a struggle for you, the other thing that you can do, remember that order does not matter for multiplication. So you can really rewrite this. You can rewrite it in a different order and then kind of group your components together, which would make it easier. So 5 times 6 would be 30. And then y to the third times y to the seventh would give you y to the 10th. Sometimes that's helpful to kind of group things as you go. Okay. So now here, I'm going to kind of zoom that in for you, make it a little bit easier. So remember that 4 is the same thing as 4 to the first. And I'm going to use kind of a distributive property to multiply each of those exponents by 4. So 1 times 4, I have a base of 4. 1 times 4 is to the 4th power. My base is x. I have 5 times 4, which would be 20. And my base is y. 3 times 4 would be 12. I could further simplify this part. So 4 to the 4th power is actually 16 times 16, which is 256. And then I could just tack on the rest of that. Okay. When you do take your exponent quiz, we will want that to be multiplied out. Okay. All right, let's do our last example. And, excuse me, in this case, if I just look at my coefficients of 5 and 7, well, that's not a fraction that simplifies. So I got 5 on the top, excuse me, and 7 on the bottom. Then I have a base of a, excuse me, and I have 3 more of those on the top than I do on the bottom. And that makes sense because 8 minus 5 is 3. And then for my b, I have 5 on the top and 3 on the bottom, which means I have 2 more on the top. And that bears out because 5 minus 3 is 2. Okay, so far so good. This section should be not so painful because it is actually a review of section 5.1. All right, so what I want to do with this, I want to kind of get everything expanded out first. So I'm going to take that 3 and apply it to everything in this first parentheses. Remember, that's a 1. Okay, and we're going to kind of do this in bits and pieces. So that gives me 1 times 3 is 3, so that gives me 2 to the third. 3 times 3 is 9, and 4 times 3 is 12. Then I'm multiplying that by 4, that's really a to the first, and b to the 5th, over 64, a to the 5th, b to the 3rd. So that's kind of a lot. So let's kind of clean that up a little bit. So let's start with this guy right here. So 2 to the 3rd I actually know is 8. So let's put an 8 there because that will kind of help things. Okay, so now you've got an 8 times 4 on the top. Well, you can actually cancel right at this point. You could do it one of 2 ways. You could cancel right here. 8 goes into 64 8 times. And then I can also simplify that 4 and that 8. And I know that 4 would cancel out and it would go into 8 twice. If you were going to just multiply those, 8 times 4 is 32 over 64. Well, that would reduce to 1 over 2. So either way you choose to do that is completely fine. Okay, now let's total up our a's that we've got going on. So I've got 9 here and 1 over there, which means I have 10. And put that here, so a to the 10th. And on the bottom I've got a to the 5th. And then as far as our b's go, I've got 12 there and 5 there. 12 plus 5 would give me 17. And on the bottom, I just have b to the 3rd. So let's get this all cleaned up now. This is still not simplified. You're getting close, but it's still not simplified. You need to get simplified as much as you can. So like we said, 32 over 64, well, 32 is half of 64. So that does reduce to 1/2, which is what we got over here. Then I have 10 on the top and 5 on the bottom. 10 minus 5 is 5. So I have 5 more on the top than I do on the bottom. And 17 minus 3 is 14. So that should be a B. Sorry about that. Let's fix that. That should be 14. So you can leave it like that. The other way you would see that, since there's a 1 there, most of the time when you see it in a book or on a test, it's going to get left off the top. And you could leave it just like that or like this. Either way is fine. Okay, that's your notes for 5-2. Talk to you soon.